Hi class! Welcome back. Now, we are going to have another new lesson for today, and that is Reliability Part 1. Okay, in our previous lesson, we were able to discuss about the norms, the frequency distribution, the mean, median, and mode, and also the normal distribution, its curves, its kurtosis and skewness. The norms pertains to the normal average performance of the group after the reliability and validity is being conducted. So now let's go to what is reliability. So in this lesson, we are going to have the first part of reliability. Now, let's go to the next page. Alright, so in this lesson, we are going to discuss about the meaning of reliability, definition, its types, factors influencing reliability, and how to improve the test through its reliability. Now let's go to the next page. Now let's go first to the meaning of reliability. So reliability is one of the important characteristics of any test. Just like what I've mentioned in my previous presentations or videos, that it's part of the standardization process. It includes on the norms, the reliability and validity. So reliability is a crucial part in constructing a test. All right, it refers to the precision or accuracy of the measurement of scores. That's why I keep on mentioning about the consistency of scores, because in the reliability, it focuses on how accurate the score, the score of each item or the test itself. Or yes, the test itself, the whole test of it. And then reliability refers to the stability of a test measure or protocol. So reliability also entails to how the test is being administered and how it impacts the test scores. Alright, so now let's define what is reliability. So according to Rosenthal in 1991, reliability is a major concern when a psychological test is used to measure some attribute or behavior. So Rosenthal in here mentioned that reliability is very important, especially if you're going to measure a construct or a certain or a specific behavior. All right, so it is very important, especially if it's a psychological test. Okay, and then let's go to Anastasi, the writer and the author of the psychological testing book. So Anastasi in 1968 states that reliability refers to the consistency of scores obtained by the same individuals when re-examined with tests on different occasions or with different sets of equivalent items or under other variable examining conditions. So in here, some of the important aspects that Anastasi mentioned is that the reliability is the consistency of scores, meaning that each item of the test shows a consistent score against other items. And also, it gives you a consistent score from the same individuals from whenever you examine the test again. All right, so this can happen after a few years or after a few months. The test scores will be the same for the same individuals. All right, and also it depends. Anastasi mentioned that reliability also will not change whether in other conditions. Like if you took the test in a classroom, your scores should be the same if you took the test again in the park or not in the park or in other areas like at home. Okay, so the test, whatever happens, should yield the same scores. Okay, so in here, Anastasi clearly stated that the consistency of scores no matter what. Okay, especially if that if the test taker is the same individual. All right. Now there are three important types of reliability. So we have the test, retest reliability, the split half or internal consistency reliability, and the parallel forms reliability or equivalent forms. So just a preview, the test retest focuses on the um, the consistency of scores in a given time. Yes, in a specific whatever the period is. So after 6 months, the test or the test scores should yield the same scores or consistent scores. The split half tends to or pertains to the performance of the test items if it is consistent with other test items. And then the parallel form reliability entails or focuses more on um, the whole test if it is consistent. All right, so again, we have the three types: the test retest reliability, the split half or internal consistency reliability, and the parallel forms reliability or equivalent forms. Now let's go to it in depth. All right, let's go first to the test retest reliability. In test retest reliability, the single form of the test is administered twice on the same sample with a reasonable gap or with a reasonable time gap. So in the test retest, that's why it's called retest, okay? Because you're going to retake the test again after a specific period of time. So for example, you took the test January, all right? Okay, so after 6 months, your test scores should be the same. All right, so you have January, February, March, April, May, June. By June, if you took again the test, you should yield the same or at least similar score when you took when you took the same test 6 months ago. All right, so in here, the test retest entails to the test of the same test, taking it twice just to measure if it is consistent in a given time. Most test retest I mean most test that is measured in test retest is the personality test. So your personality test or personality scores um, 6 months ago should be the same after 6 months. All right. So in here, the important aspects will be or concepts will be single test or the same test, administered twice to the same individuals with a specific time gap. So what would be the most reasonable time gap? For others, that would be 6 months. Okay, because this is to avoid the individuals to remember to test items. Okay, because when the individual tends to memorize what's the content of the test, he or she probably would answer the same answers of the given question. So just to reduce, I mean to decrease the chances of um, recognizing the test again and answering the same answers on a given test, you have to have at least 6 months. Okay, for others, 6 months is reasonable already. All right, for others, I think 3, but just to be safe, 6 months would be better. All right, to continue, in this way, two administration of the same form of the two independent set of scores. So once you administered the test, of course, the first one would be January and then the second one would be July. these two scores, these two different times would yield two different scores. And with these two different scores, it should have a good correlation. Okay, a good correlation would means that the test item or the test itself is a good test, or it has a very good test retest reliability. All right, so the test score from January, or the test score of January and the test score of July, you're going to, of course, get its distribution, frequency distribution, its normal distribution as well. Correlate and then get its I forgot the term, mean, and then get also the mean of the July test scores, and then once you correlate it or get its relationship, it should yield a very good countback alpha, which shows a good reliability. The two the two sets, when correlated, give the value of the reliability coefficient. So again, once you correlate it, it will show then the reliability coefficient. So it would be 0.8, 0.7. So the higher, reaching 1, would yield a good reliability. Alright, so here's an illustration of what I am talking about a while ago. So as you can see, the first one, we have the first measure, which happens at time 1, and then the second measure, which happens on time 2. As you can see here, we use the same test, the same people or sample, but in different times. So for example, just like what I've mentioned a while ago, in time 1 that could be on January, and in time 2 that could be on July. So you use the same test to the same people but in different times. So these two times, time 1 and time 2, should yield the same or consistent test results because you just administered the same test and administered it to the same people. The difference? Just the time. To continue, measure instrument at 2 times for multiple persons. So just a reminder, you should not only administer this to just one person, okay? You have to administer it to a lot of people. I can still remember in my grad school thesis, I've measured the consistency or the reliability of my instrument. So what I did is I used about 200 people or sample just to measure the consistency of the test. Okay, so in that case, you would probably get a good measure of the retest reliability. Okay, so the more the people, the better. Compute correlation between the two measures. Again, like what I've mentioned a while ago, time 1 and time 2, get its average or derived scores, and then correlate it. A good correlation, reliability correlation, the better. Assumes there is no change in the underlying trait between time 1 and time 2. So in here we have to assume, since we are measuring the standardization of the reliability of the test, we have to assume that there should be no change of scores between time 1 and time 2. Okay, so if in time 1, if the certain individual got 98, in time 2, the certain individual should get at least reaching 98 as well, 97.5 or 98 or 98.5, all right? Just on the same level, okay? So there should be no change or little change, okay? Just to make the accuracy, just to get the accuracy. All right, if there is a change, like for example, in time 1, the individual gets 98, and in time 2, the individual gets 75, it means that your test is not reliable. Alright, so here are the factors contributing to test retest reliability. So there are factors that might affect the test retest reliability of your instrument. So first, clear instructions for administrators, research participants, and raters, because sometimes the instructions affect the test retest reliability. For example, in time 1, you mentioned specifically how to take the test. However, in time 2, you did not mention it clearly. So with that, the even though the same individuals took the test, they might answer it differently. All right, and because they answered it differently, it might yield to different scores. Though you are sure that your test is reliable, and you assume that it should yield the same scores or results. But if you give the test differently, or your instructions are not that concise or clear at those different times, it will yield different results. So make sure that if you are going to conduct the test retest reliability, you have to give the same instructions to them. And also, if you give the same instructions, you also have to give the same rapport. Alright? Okay, so that's to make sure that they will yield the same scores. Next one, tasks or questions in participants. First, language or target language at appropriate level of difficulty. You also have to make sure that you use the same language the time you give the first task and the second the time you give the second time you give the test. Okay, you have to make sure that the language is the same. All right, so if you made it easy for them to understand the language on the first test, you have to make sure that the language on the second time you give the test would be easy as well. All right, again, different understanding on language as well will yield different results, even though you are sure that your test is already reliable. And lastly, an ambiguously phrased tasks or questions. All right, so if the participants wasn't able to understand your instructions, the task or the questions that you give on different times, it will yield also different test scores. Okay, so in here, just a reminder, if you're going to give the test on different times, you also have to make sure that your instructions, your language, the settings, as much as you can, have the same or are just the same. This is to, of course, get the same or similar test scores. Now let's go to the second type of reliability, which is the split half reliability. The other name for split half reliability is what we call the internal consistency reliability. So like what I've mentioned a while ago, the split half reliability pertains now to the test items. Alright. So that's why it's called internal consistency reliability or internal reliability, because this time you're focusing on the internal, which is the test items. And here it indicates the homogeneity of the test. Okay, so in here you're measuring, if you're measuring only emotional intelligence, it should give you emotional intelligence criterion throughout the test items. Alright, so it will just only, each item should give you only emotional intelligence. That's why it's homogeneous. The main goal of the split half reliability is to check if all the test items gives you the same criterion that you are measuring. So it gives you a homogeneous results as well. So what is the difference of the homogeneous kind of test items to the heterogeneous test items? The homogeneous test items gives you the same, each items of the test will give you just one criterion. However, a heterogeneous items will give you a lot of types of criterion. Okay, so for example, in 16PF, there are 16 personality factors that are being measured there. So if you're just going to measure one personality factor, you are going to stick on the homogeneous of the test. Alright? And then if you're going to measure all of it, the 16 personality factors, it entails to the heterogeneous of the items. Alright? Again, homogeneous, just the same. Heterogeneous, a combination of a lot of criteria. This method, the test is divided into two equal or nearly halves. So for example, you have a test items consisting of 20 items. Alright, 20 items. So what you're going to do is you're going to divide those test items into two equal halves. Alright, so the equal halves of the 20 items would be 10 each. So what you're going to do is you're going to divide those items into two. 10 for the first half, and then another 10 to the next half. Common way of this test is the odd-even method. So just to make sure that it is divided equally, so of course you've already divided it to the first 10 half and then the second 10 half. So you're going to divide it depending on the even and odd numbers. So test 1, or the first half, would consist of the even numbers, and then the second half would consist of the odd test items numbers. So let's go to the next. Alright, so in here, so there's a correction in the picture in here. Alright, but as you can see, we have here 6 items of the test. Item 1, 2, 3, 4, 5, and 6. So the first half would be on the upper part, and the second half would be on the lower part. So in here, there is a correction. So my apologies on that. So the first one would be the odd, and then the second part would be the even. So that should be item 1, item 3, item 5. And then on the lower part, which is the even, we have the item 2, item 4, and item 6. So what you're going to do in split half reliability is you're going to get the average as well of the odd, which is the item 1, 3, 5, 7. Okay, you're going to get the average of it, and then the average of the even numbers as well, which is the item 2, 4, 6, and 8. So you're going to get the average of it, and then once you get the average of it, you're going to get its correlation. So in here, it shows here that the correlation is 0.87. So that's actually a good correlation. So in here, it means that the split half reliability of this test item is very good because it's 0.87. Alright, so again, the odd and the even item numbers should be correlated to see its relationship, and if it has a good relationship, it means it has a good homogeneous reliability. Further, split half reliability indicates that subject scores on some trials consistently match their scores on other trials. So in here, what you can do is in other people, what they do to just get the good reliability is they administer it to the same people. All right, for example, or the same sample. So for example, there are 20 samples. Okay, so that's little, but just an example. There are 20 people who are going to take the test. Okay, so the first one, they will administer the odd number items, and then after they administered it, they will administer the even item numbers, okay? So they administered it not on the same time, all right, but in different times, but in the same people. So from there, they're going to get again the average, and then they will correlate it. From there, they will get the split half reliability coefficient. So what are the factors contributing to split half reliability? So in here, there are factors affecting the split half reliability. So let's go to it one by one. First, careful item writing, guided by item specifications. So, like what I've mentioned a while ago, the split half reliability pertains to the test items. So for you to get a very good split half reliability, you have to make sure that each item is also consistent to your criterion. So how are you going to get that? You have to have your table of specifications, which includes the construct that you're measuring, which is, for example, intelligence, and then a very good criterion on how the intelligence is going to measure. Like, for example, the intelligence would measure on the math ability, the English ability, and many more, or understanding ability, right? So that would be on the criterion part. So before writing a test item, make sure that you have, or your construct, which is, for example, is intelligence, is very clear. All right, and also once you already have an idea of your construct, you have to make sure that the criterion to measure intelligence would be a good measure of intelligence, which is the criterion. All right, so you have to establish first the specification of the test item. All right, so you have to establish that first before writing it. So in split half reliability, one of the contributors is, of course, the table of specification, or in simple terms in here, the item specifications. Next, we have the field test and item analysis. The field test entails on administering the test as well. Okay, so just like my example a while ago, so you're going to administer it on the same people, but what you did is divide the test first into equal parts and then administer it one by one. And then also, that's for the field test, the item analysis, which the item analysis will be discussed after discussing the reliability. All right, so the item analysis. So is the item difficult? How difficult it is? Is the item gives a good division on the test takers? Are there high scorers or low scorers? So that includes on the item analysis. So one of the contributors on the split half reliability would be the field test and item analysis. And then last for the slide is the construction of tests with reference to item performance. Item performance will also be discussed on item analysis. So if the item performance, is that easy, difficult, or hard? That depends. Okay, so that's the factors contributing to split half reliability. All right, so that would be the end of the end for the first part of reliability. So I would just like to give credits on the person for the content of this presentation. So thank you very much. If you have any questions, please let me know, and I'll be seeing you again on our next video. Thank you very much. I'll be seeing you then. Bye for now.